Good morning, everyone. I decided to come live 9:30 a.m. to 10:30 a.m. on the topic electromagnets concepts to commercial products. This topic appears simple, but truly speaking, every simple topic, as it appears to be, whenever we are going to study the details, the depth into, you will find the things are not that simple. This you will understand if you are working. If somebody is not working, only studying and listening to videos and other things, maybe he or she getting some idea, some knowledge, but that knowledge will never be complete till you are working. See, I have seen many students and parents because in the class 7 students are advised to make a small electromagnet for their study and observation. So they confuse how to do, even though they have read in the books. First thing, market knowledge should be there. What are the materials we require? Those things should be clear in our mind. And thereafter, you have to know how I procure them. So whenever you are ready with the materials, after going to market and having them with you, then only you can start doing. And when you start work, you will find some difficulties on the way. Sometimes we become hopeless because while doing, if you have a problem and there is nobody to guide us, then obviously our chapter will close there. So forget all those things. Some of my friends have joined. I could see. So good morning everybody again. I was just discussing the guidelines. My sincere advice to all those who are with me, joined with me, if you find time, start doing something. And I'll be very happy if you write in your chat box those who have done this simple project during your school days, making a low power electromagnet. So I will discuss the things in detail. Uh, I have procured many things for all of you, even for me. Individually, I will go. So, what are the things we require to do? Item number one, you have to make a bobbin first, like this. How you make a bobbin, depending upon your own idea, is my main concern. Many ways are there, many materials are there with us. Some people prefer the thread pipe, the paper pipe, and at the ends they have something, again, some hard paper materials cut like this in a circular manner by blade, and then getting it fixed by adhesive. Somewhere, you will observe, even though you fix it, when you start winding wires, because of the pressure of these metal wires, this comes out and you are hopeless. So while doing the work, even though I have told you it is a simple work, be sincere in your work. You confirm that your work does not hamper your progress. See, I tell you, this joint, if we make with a Feviquick, then at least we can manage. So two sides there should be two walls, boundary walls. This is one boundary wall, that means circle cutting, and inside circle cutting again, and fix the pipe inside, glue it properly. Both sides should be ready, and then have this wire. Many of you find this wire we are having in our home gadgets like your table fan, ceiling fan, all motors, but you don't have it with you in your home. Spare. So you have to have it. So this is called the scientific name of this particular wire is magnet wire. Even I did not know. In Western countries they call it magnet wire. But in our country, people say it is called the winding wire. This winding wire is copper, and sometime aluminum winding wires are available in the market. Recently I discovered. I know, but it is cheaper. That is why they avoid this copper. It is enamel, that means it is insulated. Each single thread is coated with a polymer material, chemically coated. And this coating is so powerful, you know, during the process of current flow through this, they will be hot. Why current flow creates heat? This also you have to understand again. So when heat is produced, the materials should withstand it. Otherwise, what will happen? The insulation will melt and the layers which you have provided will be short circuited and the system will fail. Your target will not be achieved if they short circuit. And whenever you provide power, there will be fire. So one important thing I will tell you, when you are winding fine copper wire for making an electromagnet, remember you should be aware what gauge I would buy. I would prefer gauge means SWG, standard wire gauge. This particular sample which I have used here is 28 SWG. So basically for new workers who try to do something new work, they have to start from 28 SWG, starting from hardly up to 32 SWG. 32 will be little thin. Remember, higher the gauge, thinner is the wire. And lower is the gauge. Suppose I will go for 22 SWG, that means 22 SWG will be thicker than this. Diameter will be more, it will be stronger, it can carry more current. So the SWG factor, we have to be again sure what SWG I will buy. Thereafter, start winding with patience. It will take, when I started winding this, even though I have not done it with a finished manner, it took me 2 hours. So 2 hours time you have to provide for winding these wires smoothly and neatly without overlapping maximum. It should be smooth, not that here will be more, here will be less, and this will do what. Uniformity should be maintained. Now there should be two ends, end one in the starting end, and N2 is the closing end. So you can see the starting end has gone inside. I show you, and the closing end is outside because this is closing. So wrap it here and twist the wire so that this wire will not be damaged for any sort of external activities. How I have done, you see, this wire is a little thin, but when you twist 2 or 3 times, they will be stronger and your soldering work will be completed at the end. Remember, in all these activities, soldering is preferable. If you twist by your hand, that will create loose circuit and heat development will take place. So soldering is best preferred. This way connecting wires you should have with you. And thereafter, what are the other things? Other things you must have in your home a power source. I show you the power source with me is little heavy. Why I have done it heavy because I have to use it years together, not a month, not a day. So this transformer, I inform you all, those who attend my program now, I have procured from the market. This is 8 ampere rating. That means it can provide you up to 8 ampere maximum. But you are not always using 8 ampere because your loads are not designed to carry 8 ampere always. This is the maximum. So this is the primary, these two, red and black. This side I connect 220 volt alternating current, and the other side is the secondary side, which I have already repeatedly told you. Secondary sides, low voltage side, and after procuring again rectifier, commercial rectifier I have purchased. This rectifier is also of the order of 10 ampere capacity. It has got 4 terminals, 2 input, and those input points are connected at the end of 12 and 12. See, center is 0, 12, 12. It's not 12, 12, 6, 6. So 6, 6, if you connect on a breeze, you will get 12. And this is the output. Output is having positive red wire and negative it should be black wire, but I have connected yellow wire. And you have to provide a capacitor. Minimum capacity should be at least 2200 microfarad. But here I have provided only 1000. For another test it was there, so I have not removed it. But in your case it should be 2200 microfarad and voltage capacity is 25 minimum. It may be more, 50 may be more. It should be 50 and 2200 microfarad. That is standard. Thereafter my DC power is ready. This one up here, the red is positive and the yellow is negative. So I keep it there at another point because this is very heavy for me. And thereafter you have to have a rod for that, which we call soft iron. What size you require? Depending upon the pipe diameter you choose. So this is loose in my case because when I was searching about the rod. This was available. So again you have to apply your intelligence, wrap some paper with sellotape so that this is exactly tight. It cannot go down because it is tight. It is not totally tight. It is slightly tight as you can move in and out like that only. If you don't have that pipe even, for small activities, For some testing activities, a small iron rod is enough for testing. I will show you everything, but one by one. I have got one more coil. This I used for other purposes, and I today collected to show you that I do like to make these things by myself. Here you can see this is not having a circular hole. This we design for other purposes. So I had got a square rod. So for that square rod, I had this design. So that my square rod can enter through perfectly. This end to that end, as like this. But for today's purpose, I will show to you using this rod through this. It is passing through. So I have to use. See, in this case, the connecting portion is a little strong I have made, and I do have some clamps even I can show you for connecting at this point and this point. There are certain clamps in the market like this. You could press and insert the wire inside. I show you how. So you are having a wire like this and you want to insert it. How you press and push it inside and release, and you see this is tight. So for temporary purposes, this type of connectors, spring loaded connector, is very useful because you can open and close as you require. Thereafter, what are the other things you require? The most important thing is a compass. I told everything, but this is most important I told because this will be your eye opener. See, compass in the market, they are available in many forms, many size, starting from 10 rupees to 500 rupees minimum. Even more than that, they are available, but for my purpose, I say this is 150 rupees because I like that because this is the design, it is little robust. This needle is pivoted on a single tip, so it is always fluctuating, vibrating always. So this I will show you how we use it. Thereafter, for having the idea of a commercial electromagnet, again you have to go for purchase. Purchase some commercial electromagnets. This is 12 volt. This looks miniature, but this is truly powerful. I will show you how powerful. You have to purchase, right? And even better, best performance commercial electromagnets I do have for all of you to see today. This is extremely powerful and has got a lifting capacity of 100 kg. If you can lift, you can fill. If you cannot lift, choose your own load for observation. I have selected this load. This was a heavy mass on my telescope. So I have opened it. This is called a balance load for a telescope. This is minimum 10 kg. I will show you today this 10 kg load, whether this can lift or not, or if that cannot lift, whether this can lift or not. And during the time of lifting, I will show you whether they fall or not is very important. And when you lift, test, this portion should be clear, nothing, because if that falls, other materials will be damaged. So we have to go for start. The real activity will start now. I will show you first with a small power pack. 1 minute, please. This small power pack, which I was discussing about with a clamp like this, it is a very small because it is having the arrangement of supply voltage DC 1.5 to 12. By adjusting this, you can listen to the sound of movement. This is input 220. This is the 2 pin top, and these two are the output, positive and negative, for our test now itself. Because I will start with this, because for small purposes, you should not use any heavy items. This is not advised, because I show you with my commercial little, that means junior electromagnet we start with, because that will create a little fun in us. I have to connect this. Here they have got two blue wires, because for the commercial electromagnets there is no fixed positive and fixed negative. So that is why they have given both blue. That means you can connect anywhere, and we have to check. Say I connect this with red and the other one with black. And first ensure your voltage. I ensure with 12, because this is designed for 12. I will show you. They have already mentioned 12 volt. You could see, please. Am I right? 12. So now, what I do, I will test with this first, because this is very light. And thereafter, I will go for heavy. I keep it there and then switch it on. See, this has lifted. I show you anyway. Wherever you move, it will not let it go, because the strength we cannot even imagine. This is just to be verified. So you should feel that my electromagnet is truly a genius. It is having a very strong lifting power. And very interesting thing, all electromagnets, the material is always soft iron. Because the moment you switch it off, I hold it like this, and I will show you the moment I switch it off, it should release. Otherwise, this is not a electromagnet. It is dropped. Repeat verification, attached, and thereafter drop. Why this drop facility is there? Because in iron scrap loading and unloading, heavy electromagnets are used, and they are connected to the battery source provided by the crane, say of the order of 100 ampere. This is some maximum to maximum some 750 milliampere. Remember, but those commercial cranes, they have electromagnets which carry 100 ampere and big. So when the current is flowing through, they got magnetized and they lift heavy iron scraps, and the crane moves, and then the dumping will be again on the truck for carrying and transporting to the smelting factory. Now we try with this product whether we have to see whether this can be lifted or not. You see, commercial electromagnet they do not have a very long distance drawing power. Remember that I will again show you. They cannot attract it from a long distance, but from a short distance, if they attract, the pulling strength is very high. That means that they will not allow the things to escape. You see, getting lifted. Such a beauty, if you do not work with that, I hold it, this does not fall. I hold this, even though this is a very big material for me to even balance because I am having a small point to hold. This is not falling. And if you release the power, you see, it has dropped. Like that only, dumping is done by electromagnets. But now we have to try if it is possible for pulling this or not. It will attach, but may not be. I am not possible. No, I don't find it possible for me even to pull it. You see, that has been attached. I show you. Here is a gap. Here is a gap. Suppose, and you just feel how it is getting attracted. Yes, there is a sound, and it is there. I cannot detach, even though I pull it strongly, even though I hold it even, and left side pulling. No, I can shift left right, but I cannot detach. So this is the beauty of the electromagnets. And now I want to show you whether this is possible for us to lift at this point or not. It is already tight. When I lift it, this escapes. See, because that one is heavier. No, not possible. Because the maximum lifting capacity, as mentioned by company, they have tested it. You can see they have mentioned it 3 kg. You might see that 3 kg. So when that has been designed for 3 kg, how do you expect that this will lift 10 kg? Certainly not. Okay, I think we start with a very entertaining demonstration. Now, what are the things that could lift this? There is a small bolt that can be easily lifted. This got lifted. This got attached but could not lift. And now we have to discuss about why I need a compass here. That we will discuss first. See, your compass always detects north and south. We must ensure first. Until unless you are having a magnet nearby. So for me, this direction is north and this is south. Then what I am doing, I show it to you this item, the coil which I have already prepared. So what to be done? Maximum power to be provided. I have told you these are the things very suitable for providing power. So I clamp it here, and the other point I will just touch. Let me supply the power pack. Power is ready. We test with low voltage so that this coil should not be hot. And now observe this compass, and when I touch the terminal, even though there is no iron inside that, you will be happy to note that the needle gets deflected. And there is a very interesting item now I am going to present. If you periodically touch and untouch, that means make contact and discontact. So connect and disconnect, on, off. This will start rotating. I will show you now. And this is like a motor. So using electromagnet, you are able to show that by a suitable on and off arrangement, you are able to rotate the needle around this axis. But our target was not to show the rotation. Our target is to show at what distance this electromagnet will be able to have an impact on this commercial needle. You just see. This is south end, this is north end, and my black terminal is here. And I always observe here the south end is getting attracted. Let me observe if the south end is getting attracted or not. Insert this rod through this and strengthen the magnetic field, and you will be happy to note that we can truly verify whether this was attracting or this was attracting. I could confirm that the south end of the needle is being attracted towards my black terminal. You could see. Very interesting. Now, if you want to attract the north end of the compass towards this, what you have to do, observe. Connect the black here at this end. Remember, I connect the black here. Interchanging the position, I have connected. You also see. And now I have this red terminal for make and break here, and you will be happy to note, even though the compass is little away that side, this red end will be coming this end. Let us verify. See, the needle is very vibrating, so you should wait for certain time to confirm that it should be stable, and you observe properly that this north end is now getting attracted towards my red terminal. So funny. Truly interesting, because science education is very interesting if you demonstrate and if you work with yourself. See, this is not going now. Why? Can somebody answer? Why this is not going back? Because this rod has been magnetized, and it has retained the magnetism, and this particular pole behaves the south pole. So being south, it is attracting the north of the other magnet, because north and south of two magnets, they attract always. Very interesting. If it is a fact, I will show you. I will take the rod out and I will insert this end and we will see whether the opposite happens or not. Yes, happens. Now the south end is getting attracted and we will again verify whether the north end is coming if I reverse it or not. Yes, coming. What does it mean? It means this rod is not perfect soft iron. This is little hard, carbon content is little more, and once you magnetize, the magnetism is preserved. It is not getting out from this rod. So this is very important for our information. Now, please be ready. We have observed the verification using this coil. And now I will show you this is the purpose for which we use the compass. And now again I use it for observation of attraction to other materials or not. What are the other materials? Small materials. We must see. These two are small materials. And if I provide power here, and let us see whether this material getting attached or not. Yes, this is attached. Now, if you switch it off, it should fall down. It's not falling down because I have already told you this retains the magnetism and does not back it out. Same thing we will see with this material, whether this attracts or not, but little bit heavy for this. So this is falling down because the pulling capacity of this particular rod now it is see one more important thing I will tell you from this distance this is falling, but if I take the rod inside you will be happy to note that this will not fall. Observe carefully. My light is there. This is not falling. I saw it. But observe again, if I take it a long distance, it attracts but it cannot lift. It falls. But here, if you take it back to the face, that means the strength of the electromagnet is very high at the face, at the opening. See, this is there. I show you with light, I think, because that is getting little dark this side. I show you here. You can take a note. It's very interesting. I like it very much because this opens our eye always how science behaves. And if you study science properly, you'll be able to study other things properly. Now I shift to one more coil. Uh, why I shift to one more coil, I will tell you the reason behind. The reason behind is like this. This is a thin wire. This wire has got the capacity of carrying less current, and electromagnets actually they need a little more current for becoming a strong electromagnet. I will show you now how to make a little strong electromagnet. I have already shown you this particular coil which I have made. That wire is 34 and this wire is 28. So the difference is this is capable of conducting higher current of the order of, say, for example, 1 ampere. Now, what I do, again, the same process I will follow. These terminals, I will connect. with black. So my yellow is connected with black, and my red is connected with red, and terminals I will be taking it away, and the same process we have to follow again. You have to check what pole is getting attracted towards the. You could observe the needle. Let me power it on. The same thing. The same south pole is getting attracted. And now let me reverse the connection. So what I am doing, the red will be with yellow, and the black with red. And let us observe whether the compass red end is coming this way or not. So please be ready. Perfect. It is as expected. The red end is attracted now towards this face. Now switch it off. This is best for testing because without iron, this is best for testing all the characters of electromagnet. And I keep it there a little bit away. And again, have the same small rod and test with. It will have a impact. That means from a distance, it will attract. You can check. And the moment I increase the length, it will be better because magnetism has been proceeded. It has advanced to this point. This is beautiful. This has come to that point, so it is becoming stable now. And now, one thing we have to observe, if this end is attracted, that means if this is north end, this is south end. If this is south end, the other side should be north end. So we have to again observe, if I bring the magnet here, the other pole should be attached. Now you could see the south of the compass is getting attracted toward this. So the electromagnet, that means a solenoid, this is called the solenoid. Whenever you are applying current to the solenoid, one end must be negative, north pole, and the other one will be south pole. If you reverse the current, again that is again interesting. So observe, this is north, this is south. When the black is with red, and now when the red will be with red, you will observe this polarity, the pole condition will be reversed. You see, immediately the north pole get attracted. That means it has become the south pole. So when this is south pole, obviously this side is north pole. Confirm again. Why? Because this is north and this is attracting south. I shift a little bit. So beautiful concepts we are discussing one by one. And now, what I shift my focus from this particular rod to the diametrically larger rod. And what I'm doing, I push it inside. You can see this has come to this point, and I just get it here. And I have already told you the strength of the electromagnet is highest at these two ends only, here and here, here and here. That we have to have a test now. How to have a test? This is the test material for us. I will provide power and I will show you that this has got a attraction capacity from a distance. I hold it here at a gap and you will find when I power it on, this must attract with a sound. Yes. And now what is the proof of a strong attraction? I show you with this small rod I am hanging this weight. See the weight of the coil and the weight of the rod together. I just guess it will be minimum 200 gram. And for your observation, this 200 gram, this is able to lift. And if I use this way also, I'll show you. This is also possible, not falling. Even though point of contact has been reduced, even though I do it like this, I can show you this is possible for me. Now, this is why I told you the strength of the electromagnet depends upon the current. This is the load. Now, what I am showing you with a particular this bolt, whether it is possible or not. See, this is not truly a soft iron, and that is why the magnetic pull, even though it is there, but not that much. Now, let me test with this 10 kg load, whatever I am having here. Suppose I am having here, it is getting attracted, but not possible. So this was the idea how we measure the strength in terms of lifting power. And thereafter, I will show you with one more information. The information is like this. I have to use now this. Yesterday, I had uploaded a short video and I am showing you all my viewers who are present here. Even though nobody is here, I am having this presentation for all of you so that you can see if you like this program in future. This is a very pity matter. I every time discuss, even though I could find 8 viewers gathered to me, at this moment it is zero. Okay, no problem. People do not like science. People like to see repeatedly. I see people like to see the face of others. Now, what I'm showing now. I connect the terminals red with red and black with black. So what I'm doing, I will show you. Even this will be a magnet, but the current required by this electromagnet, this power supply smaller one is not able to provide. How? First, I show the attraction with this rod. Ready? First, let us see whether it attracts or not. Oh, fine. Listen to the sound. That's beauty. Now, what I'm doing, I hold it like this and let them attract, and then I lift, and you could see this is getting lifted. So, this is, I think, around 2 kg. So, my rod is able, with the support of the electromagnet, to lift 2 kg. This is beautiful. Similarly, uh, you have to see using this small current whether our electromagnet can lift this or not. This is very interesting observation, all of you. Have a Good observation. I'm getting ready. Pressing the switch on. It has attached. You could feel because I'm applying my strength. But okay, let us see. Let me pull. Oh, that's great. Even with 1 ampere current, because this power box can provide 1 ampere. So this is 1 ampere current is strong enough. I show you this way. I hold this magnet here by my support here, and at this point there is no support, only attraction between the poles, and this does not fall. That means this is truly amazing. Now I have to pull and show you whether I can pull it or not. No, no. So with 1 ampere, this is not possible for me even to pull them back. So imagine if I use that 8 ampere transformer, the strength of the magnetic attraction will be increased by a large amount that I will show you. Now there is no power, so no pulling. So get ready. So what I'm doing, I have to connect my terminals like this. How I was doing, I tell you, connected. And my yellow terminal should be connected to this end. They are connected. And now this is having another two terminals. So they need to be connected. I have not soldered here. So what I'm doing, I just connect like this. Interesting. It's very easy way of connection. So they are connected both side mechanically with strength. Now my heavy duty power pack is ready. This is my heavy duty power pack. Let me power it on and I will show it. What is the pulling power now compared to before? Are you ready, all of you? I have a gap now, and you observe the gap has increased. See, this is pulling from a distance. Let us find. No. Yes. So at this particular point, let me test again. Not falling, even though I have control like this. See, this is at one end. I balance it like this, and I hold it like this, and that does not fall. And now, what I am doing, I have to show you. Let me try with the other rod. What happens? Let us see. Okay, beautiful. The same way, same result. And now for testing with this, I have already told you this has been designed for 100 kg. You can see they have mentioned it. I'm not joking with you. Could you see 100 kg load carrying capacity? It's not it's not a simple thing. You have to understand 100 kg. Even I cannot lift 30 kg beyond. So bodybuilders can lift hardly 150, 200. So get ready. I provide power this way. This is the side you have to apply always, not the other side. And get ready. Already attached. Yes. With that I had sewed. With this I am sewing. Again like this I am sewing. This is very interesting. I want to detach. No. This is why the knowledge get consolidated by doing experiments. You want to experience the life. So now I'm getting ready to end my program, but before I end the program, let me show you that when I power it, how is the pole character of the compass to be verified. Let us see. Oh, so strong, you can see. You see, this side north and this end is south. It's not able to detect because the pole is dominating. So that's what now the idea is like this. Now before I end, I do not know whether there are somebody who can review it or not. Last some minutes. First, you have to review my program, whether you like this program or not, and thereafter, I find somebody has written, "Is that human hair?" So, what is that human hair? I do not know. But are you expecting the human hair to be used in electromagnets? And another student has joined. So, see the expectations from our Indian community. They say, Is that human hair?" So, at the end of the discussion, I could tell you that people expect human hair to be used in electromagnets. So, this is the development of India. Nowadays onwards, I request you, Bhaiya, extended delta, remove your hairs, make them thread, and wrap in your electromagnet and see whether that can attract the iron or not. If it attracts, then show me the video at least. And I'll be thankful to you because you have studied from your own experience. Any other concept, no idea mm, getting generated from other viewers? So it is 10:29 and I'm getting ready to wrap the program. No suggestion from anybody? I think nobody is there, so who will suggest? It is totally zero. Let me see. I do not know because I have committed to close at 10:30. So I will close it by 10:30. Does not matter to spend one more minute here with you people. But the live program should have a lot of feedback. And I have conducted so many live programs, but no feedback is coming from anybody. I do not know. People, especially this young generation, they do not have interest in these particular demonstrations of life, because they don't have time. They have time to see pictures of others, not these lifeless objects. So thank you all. With a big thanks to all of you, those who joined. We meet you again in the next program as published.